Okay, if we're looking here, we've got a couple. Okay, now a couple, the definition is two forces. So here we got two forces of equal magnitude. So this one shows that. They're acting in opposite directions. All of these show that. Whose lines of action are parallel but separate. So all of these are parallel. All of these are not on the same line. What I mean by the same line is if it's like that. Okay, there's no turning moment if it's just a straight line between the two. So these things create a couple. What does a couple create? It creates pure rotation. Okay, it just spins around on the spot. How do we calculate the size of a couple? Essentially, the thing is called torque. Okay, it's got the symbol torr. How do we find the formula? Let's look at the moment created by F1. So F1, the pivot is in the middle there. It's going to be the force 1 multiplied by distance divided by 2. Okay, diameter divided by 2. The other one's going to be F2 times diameter over 2. What's the total moment when we add the two together? Okay, adding the two together where the two forces are of equal size, we actually get 2 times F times D over 2, and if you then tidy this up, get rid of these 2's, they cancel out, you're just left with force, one of the forces multiplied by the distance between them. Okay, and that gives you the formula for a couple. What's the units? Well, it's just Newton meters again. So in this case here, the spinning top is made to spin with two equal opposite forces of 5 newtons, 5 millimeters apart on the shaft. Calculate the torque produced. Okay, so if you're looking at this thing downwards, okay, there are two forces on this thing, equal in opposite directions, both of 5 newtons, and the distance between, I can't draw that, is 5 millimeters. So torque is equal to force times distance between them, and the force in this case is 5 multiplied by 0.0, 5 millimeters. Okay, and you find out what that is equal to. Okay, 0.025 Nm, making sure you're in meters. Now, in class, I'm going to talk about a few other ones, but if you have this object there, okay, let's just have a look at this object. Doesn't want to make a shape. So, if I have this object here, and I put two forces on it, let's create two forces. So there's one force, and there is another force there. Okay. Now, if these two forces are of equal size, so 10 newtons, 10 newtons, then it doesn't actually matter where this force is located. It could be down there, it could be up there. It doesn't matter in terms of a couple, as long as the definition is followed. We can say that this thing is always going to spin around the center of gravity. Okay, that one is a confusing one to think about. And here's some websites you can go to. There's websites all through it you can look at in your own time. Da